welcome to IITA weather station. On the board there shows the year of establishment, that is 1973. At these GPS locations. Then at the elevation shown on the board too. We collect 2 times in a day, 7:30 in the morning and 15 hours in the afternoon. Listed there are the parameters we collect on daily basis. The purpose of the weather station to IITA, which is a research center, cannot be overemphasized, because without all this information, research is not completed. Can we now go to the field and see some of these things one-on-one? Here is the weather station proper. The first point of call when you enter a weather station is the cup counter anemometer. The cup counter anemometer measures the wind speed. You can see how they are revolving, because with the wind, some of the crops will be properly perform very well. Like in maize needs the wind to pollinate. That's cross-pollination. Now you can see we have them at 3 levels. These are at 2 meters, this is at 1 meter, and this is 50 centimeters. So the principle is like a car speedometer. You copy the figure here and subtract it from the figure of yesterday. Then the difference you divide by 24. So that will give you the wind speed for that day. And is in kilometers per hour per day. Here is another equipment. This one is called Campbell Sunshine Recorder. Campbell Sunshine Recorder measures the duration of the sun per day. It goes with a card. The card, we call it Sunshine Card. So each day we fix this card. You can see the burning. These lines are graduated that is 1 hour, 2 hours, 3 hours, like that. So at the end of the day, you remove this card and use a template calibrated in millimeters to measure the area of the burn. Then you total it, that will give you the duration of the sun per day. This is another piece of equipment. This one we call solarimeter. Solarimeter measures the intensity of the sun per day. That one gives us only the duration of the sun. That is the number of hours of the sun per day. But this one gives us the intensity. That is when the sun is high or low, to measuring it. This one is a rain gauge. And this type we call automatic rain gauge. So automatic in the sense that whether it's raining in the night, you don't know when the rain started, this one will tell you that the rain started so time and it stopped so time. And it will give you the intensity of the rain. That is the number of times you had rain for that day. So this is a collecting bucket and the funnel. It has a chart. The chart is here. This is every after work. So all the information are transferred here on the chart. As we saw on the board there, this is called Stevenson's screen house. You can see it's painted in white because white reflects heat. So with this one now, it gives us the idea of a temperature in a room. So here we have equipment. This one we call hygrothermograph. Hygrothermograph measures the relative humidity. It gives us the minimum and maximum relative humidity. And the hygrothermograph means it's measuring both temperature and humidity. So this piece of equipment is giving us that information. Here too, we have what we call dry and wet bulb thermometer. Thermometer measures the atmospheric temperature. So here now gives us the wet bulb gives us the idea of a temperature of a wet region, while the dry bulb gives us the idea of a temperature in a dry region. Also, we have what we call day and night thermometer. That's the layman's language, but scientifically we call it minimum and the maximum thermometer. It's called day and night because the maximum occurs in the afternoon, that's the day, while the minimum occurs in the night. So that's the night. So it's called day and night thermometer. It measures the atmospheric temperature. Okay. You can turn around here and see these are the soil thermometers as we see on the board. Scientists we like to know the idea of temperature at any depth before they start their experiment. This we call Class A pan evaporimeter. This equipment is measuring the amount of water being taken to the atmosphere, and that is called evaporation. So it's having a screw gauge. Each morning you adjust this screw so that the tip of the water there will be at this tip of the hook. Then you subtract it from the figure of yesterday, so the difference now gives you the idea of the evaporation of the previous day, and is in millimeters. Now I told you that we use the value of the water in the rain or the rain in the true check to compute this, because if it is raining, you don't need to touch the other rain gauges, but you take the idea of the rain there, add it to the previous figure of this evaporation, and subtract from today's one. So that will give you the evaporation of the day. This setup here is called automatic weather station, or you can abbreviate it AWS. You can see we have 4 stations here. They are doing the same work we have been going around to see. Like Stevenson's screen, we saw there. This is Stevenson's screen. So inside it is the sensors for humidity and temperature. Then this is the rain gauge. This one does the work of fan evaporation we saw there. These are the soil thermometers. You can see they are more than even what we saw there. This is the cup counter thermometer up there. And these stations, you don't need to come here every day. That's why we call them automatic. You stay in your office there, put a pin, and you can download the information. Like this one now sends information to a computer in that office there. This one sends information to our office in building 401. This one sends to our partner in UK. So you can see the advantage of this. It's occupying a small place. A farmer can give you this small place, but the farmer will refuse to give you the whole of that. So that is an advantage of automatic weather station to conventional weather station. Another advantage is you are getting real-time data. Like if I want to know the temperature right now, I go there, I will get it. Other ones, or these ones we have seen, cannot give you that. So, but everything that has advantage has also a disadvantage. Like now, it's very difficult to maintain, and it's very costly. And another advantage, it has a battery, though we support it with a solar panel. The battery can fail. You come in the morning, you see everywhere blank. So this is all about IITA weather station. Thank you.